Hello everyone. In the previous video, you learned about random variables, which are defined as a function or a process of assigning numerical values to every element of the sample space. Now, you also learned that there are two types of random variables, which are the discrete and continuous random variables. When we say discrete random variables, the numerical values assigned to every element of the sample space result from a counting process, while for continuous random variables, the numerical values assigned to every element of the sample space result from a measuring process. Now, you also learned that whenever there is a random variable, there is an associated probability distribution function that shows all the probabilities that shows each probability of each possible value of the random variable x. So you also learned that an important property of this probability distribution function is that all the probabilities are non-negative and the total of all the probabilities would be equal to 1. Now, for this video, we shall focus on the mean and the variance and as well as the standard deviation of a random variable x. Remember, a random variable assigns numerical values to every element of the sample space. So the set of all numerical values assigned to those elements may form a data set. So if we have a numerical data set, we can compute for its average or its variance or its standard deviation. Now let us consider first a particular situation to introduce the mean of a random variable. So let us suppose that two coins are tossed 16 times and the following table here shows the outcomes of the 16 tosses. So in this case, though, there are four possible outcomes. It could be head, 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 tail, tail, head, or tail, tail. Now, for this particular situation, let us define a random variable x that represents the number of heads per toss. So meaning each outcome will be assigned with an x value that corresponds to the number of heads in the outcome. So therefore, if we have the outcome head tail, it will be assigned with x equals 1 because it contains exactly one head. Now for tail tail, it will be assigned with x equals 0 because there are no heads in this particular outcome. Now for head head, it will be assigned with x equals 2. So for the 16 tosses, we have 16 numerical values assigned to every outcome of the 16 tosses. So the question is, what is the average number of heads per toss, or what is the average number of heads from the 16 tosses that we performed in the two coins? So to get the average, we can simply add all these 16 values and divide it by 16. And therefore, in this case, we get 17 over 16, which is 1.0625. So this value is the expected number of heads whenever we toss two coins. So that means every time that we're going to toss two coins, we're going to expect that there would be one head in the outcome. No? Because 1.0625 no, is close to 1. Okay, now, the random variable x that we considered in the situation is has the mean or that has the mathematical expectation. Okay, so yung mean of the random variable x, it's called the mathematical expectation of x. So in our example, the 1.0625, again, as I said earlier, it's the expected number of heads whenever we toss two coins. So therefore, we expect always that there would be one head in the tossing of two coins. Now, the mean of a random variable x can also be computed using the probability distribution function. So as you can see in this table, the possible values of x are 0, 1, and 2, and their probabilities are 4 over 16, 7 over 16, and 5 over 16 respectively. So these probabilities that came from the table that you saw earlier, in the assignment of values. Okay, now how do we compute no, the mean of the random variable x based from a probability distribution function? So we can do that by multiplying the value of x with its corresponding probability. And then we do it for all the values of x. Now, once you have all the products, you add all these products and you get the mean of the random variable x. So that is 0 times 4 over 16 plus 1 times 7 over 16 plus 2 times 5 over 16. And we get 17 over 16 or 1.0625, which is the same uh, quantity that we got whenever we add all the 16 values and divide it by 16. So formally, the mean of a random variable is denoted by the Greek letter mu with a subscript x, or it can be represented by E of x, which means mathematical expectation. And then this is equal to the summation of the products of x and its corresponding probability. Now, other than the mean of a random variable, we can also compute for the variance and the standard deviation of a random variable x. So the variance of x is denoted by the Greek letter sigma with a subscript x squared, and it is equal to the expectation of x minus the mathematical expectation quantity squared. And this is equal to the summation of the quantity of the value of x minus the mean quantity squared multiplied with its corresponding probability. So this formula is actually based on the probability distribution function or the probability distribution table. Now we can also denote the variance of a random variable x by VAR of x, and the standard deviation of the random variable x is defined as the square root of the variance. So once we have the value of the variance, we just get its square root to get the standard deviation of x. Let us have an illustration. So let x be a discrete random variable with probability mass function given as follows. So the possible values of x are -1, 0, 2, and 4. And the corresponding probabilities are 1 over 7 for -1, question mark for 0, 2 over 7 for x equals 2, and 1 over 7 for x equals 4. So the question here would be, what is the value of the probability that x is equal to 0? Or meaning, we're going to determine the value of this question mark. So since we know that this is a probability distribution function, the total of the probabilities should sum up to 1. So in this case, we shall add the given probabilities in this table and then subtract it from 1 to get the probability that x is equal to 0. And this gives us 1 minus 4 over 7, which is 3 over 7. Okay, now this time, let us compute for the mathematical expectation or the mean of the random variable x. So for the mean, we multiply each value of x by its corresponding probability. So in this case, we have -1 times 1 over 7 plus 0 times its probability, which is 3 over 7, plus 2 times the probability 2 over 7, plus 4 times the probability 1 over 7. So in this case, we get 7 over 7, which is equal to 1. And that's the mean of the random variable x. Now, to get the variance of the random variable x, we shall use the formula in the previous slide. So it's sigma sub x squared or bar of x. And this is obtained by subtracting the mean from the value of x. So we have -1 minus the mean, which is 1. And then we square it. And then we multiply it by the corresponding probability 1 over 7. And then we do that no, for the rest of the x values. So for x equals 0, we have 0 minus the mean, which is 1, quantity square, times its probability, which is 3 over 7. And then plus, for x equals 2, we have 2 minus the mean, which is 1, quantity square, times its probability, which is 2 over 7. And plus 4 minus 1 quantity square times its probability, which is 1 over 7. So just use your calculators to compute the exact value of this variance. Now, whenever you have the value of the variance, the standard deviation is computed as the square root of the variance. Just use your, again, just use your calculators to compute the standard deviation of x. Okay, now if we want to get the probability that the random variable x would be from 0 to 4, we go back to the probability distribution function or probability distribution table, and we only consider those x values that would satisfy the interval from 0 up to 4. So the x values that will satisfy x between or from 0 up to 4 would be x equals 0, x equals 2, and x equals 4. So if you want to get the probability, then this is just p of 0 plus p of 2 plus p of 4. And P of 0 is 3 over 7, P of 2 is 2 over 7, and P of 4 is 1 over 7, and that sums up to 6 over 7. Okay, let's have another example. A student organization is raising funds by selling 300 raffle tickets worth 20 pesos each. The sole lucky winner of this raffle will receive a prepaid cell phone card worth 1,000 pesos. What is your expected net gain if you buy one raffle ticket? So in this problem, the random variable x represents the net gain, okay, in this particular scenario. So which means every ticket will be assigned by the price minus the cost of the ticket. Okay, so let's say if you're going to win in this raffle, you're going to win 1,000 worth 1,000 peso cell phone card. So you have to subtract the 20 pesos that you spent, no, in buying the raffle ticket. So 1,000 minus 20 will be 980 pesos, and that's the net gain of the winner. Now, if you are unfortunate, if you lose in this particular scenario, then that means you're going to lose 20 pesos. So here, there are two possible values of x, the positive 980 and negative 20. And the probability of winning, or the probability of getting this 980 pesos net gain would be 1 out of the 300 raffle tickets. While the probability of losing 20 pesos will be 299 over 300. But for this scenario, we're looking for the expected net gain. So this would imply that we're looking for the mean of the random variable x or the mathematical expectation. So for this case, we get 980 multiplied to 1 over 300 plus negative 20 multiplied to 299 over 300. So just compute the following using your calculators. In case that the mean here is negative, then that means every time that a player would play this game or would or every time that the player, would buy a raffle ticket, then that means that the student will always lose or will always lose money. Okay, and then if the mean is positive, then that means that the student will always gain an amount. And then whenever the mean is zero, that means that this particular situation is a fair game or a fair situation. Okay, for the next example, let us suppose that an urn contains 100 identical sealed envelopes. 10 of these envelopes contain 300 pesos each, 20 contain 100 pesos each, and the rest are empty. Now you get one envelope from the urn and win the content, if any, of the envelope. What would be a fair price to get the chance of selecting an envelope from this urn? So what we want to get in this particular problem is the amount that we're going to pay in order for us to have a chance of selecting an envelope. So let us let M be this fair price. So M is the fair price of the envelope. And then X is the random variable representing the net gain in this scenario. So the net gain is obtained by subtracting the fair price from the amount of winnings. Okay, in this particular game, no, if let's say we win 300 pesos, then that means the net gain will be 300 minus M. Now, in case that we win 100 pesos, the net gain is 100 minus M. But if we get an empty envelope, then that means our gain will be 0 minus M. Now, the probability of winning 300 pesos is actually 10 out of 100 because there are 10 envelopes with 300 pesos inside. And then the probability of winning the 100 pesos will be 20 over 100, while the probability of not getting any of the amounts will be 70 over 100. So in order for us to solve for the value of M, we shall use the property of the probability distribution function. So in that case, uh, we can multiply each value of x by its corresponding probability. So we have 300 minus M times 10 over 100 plus 100 minus M multiplied to 20 over 100 plus 0 minus M or negative M times 70 over 100. And we shall equate this to 0 because we want this situation to be fair. Again, if the situation is fair, then that means the expectation is equal to 0. Now, solving for this particular equation using algebraic methods, we will find out that M is equal to 50. So that means the fair price would be 50 pesos. So if you're going to buy an envelope, you have to pay 50 pesos for a chance to win either the 300 pesos or the 100 pesos. Okay, and finally, we have the following example. Peter and Sheila are deciding where to invest the cash gifts they received from their godparents during their recent wedding. They were presented with two investment options by their financial advisor. The amounts to be gained and the corresponding PMFs of these two investment options are shown in the table in the next slide. Compare the profits from these two investments and help Peter and Sheila decide which investment to choose. So in this particular table, we have investment A and investment B. So for investment A, the probability of getting a profit of 7,000 pesos is 0.7. The probability of getting a profit of 3,000 pesos is 0.25. The probability of getting a profit of 1,000 pesos is 0.04. And the probability of getting a loss of 500 pesos is 0.01. So in a similar manner, these are the profits for investment B and their corresponding probabilities. So if we want to help Peter and Sheila, we must find the expected value of X for each of the investments. So for investment A, we have 7,000 times zero point 0.7, 3,000 times 0.25, 1,000 times zero point 0.04, negative 500 times zero point 0.01. So similarly, for investment B, we shall multiply the profits by its corresponding probabilities. So if you get the sum of those products, you'll get the expected value of X for investment A and expected value of Y for investment B. Now, if you use your calculators, you will find out that the expected profit for investment B would be higher than the expected profit from investment A. So therefore, Peter and Sheila must invest in investment B. So just do the computations that were explained for this particular scenario and you'll find out that investment B is better than investment A. So this ends the discussion about the random variables and the mean and variance of the random variable. In the next chapter, we shall discuss the different types of discrete probability distributions.